And this is a similar one as you took in O levels, the work energy power. So I do expect everyone to just recall this idea. So I will not go in too much details of this. So what is the work done when force is applied on the object and the object move? What we call that as a work done. So basically, what is work done? Work done is equals to the force multiplied by distance. But sometimes the force is not making like force is not exactly same as the direction of the motion. So in that case, we have to take the component of the force. Example, this is the formula valid when the direction of the force is same as the direction in which the object moves. Like this is a motion of the object and the direction of the force is also same. But what will happen if the force is making certain angle? So in that case, there is a force is also having the component, like if I say the object is moving towards right, that's a direction of the motion. But the force is not exactly towards right. A force is making certain angle. So if the force is making certain angle theta, so we will have two components of the force. The one of the component which is horizontal, and how we'll get this horizontal component of the force, that will be equal to F cos theta, and the other one will be vertical component of the force, that is F sin theta. So which component of the force is responsible for the motion towards right hand side? F cos theta or F sin theta? So F cos theta is responsible. So when we calculate a work done here, so in this case, the work done will be equal to F cos theta into D. Then energy. What is energy? Energy is ability to do work. That is called energy. When work is done, the object will have energy. Some of the energies are stored and some of the energies are transferred. Like example, there are different forms of energies. Different forms of energy. We have kinetic energy. Moving object will have kinetic energy. Gravitational potential energy. It is energy stored due to change in the height. Elastic strain energy. It is energy stored when the object deforms, changes shape, size, length. Heat energy or internal energy. The energy, the sum of kinetic and potential energy of the particle. It can be heat or thermal as well. The the change in internal energy, like example, when object transfer the energy, like if hot object is there, it will have high internal energy. When it cool down, its internal energy decrease. So how much internal energy decrease? That is known as thermal energy. Then sound energy, energy due to the vibration of the particle. Light energy, the energy due to the wave or transfer in the form of wave or electromagnetic wave. Electrical energy, energy in the moving charge. Nuclear energy, the nuclear energy, energy which like produce or stored in the nucleus and can only be released by nuclear fission or fusion. But in this topic, you just have to know the formula of two of them. Elastic strain energy, we will discuss the formula, but not in this topic. That is in the materials and fluids. Kinetic energy is equals to half mv square, and potential energy is equals to mgh. And according to conservation of energy, energy cannot be created nor be destroyed, but changes from one form to another. And what is power? Power is able rate of doing work, means how much work is done in a unit time. So the formula for power is equals to work divided by time. And it can also have another formula. Work is force into distance, so force multiplied by distance divided by time, and distance divided by time, what is distance divided by time, is speed. So power is a product of force into speed. But what is the meaning of this? What is this speed? This speed, because if there is a force, this is not the resultant force. Keep in mind, this is not the resultant force. This is a driving force, the force required to keep the speed constant. That force you will substitute. This is not the resultant force. And what is V? V is a constant speed, the speed at which the object is moving. So example, if there was a car, so this is a car, and this car is experiencing a air resistance of say 200 Newton, and the car was originally moving with a speed of 100 kilometer per hour. To maintain this 100 kilometer per hour, how much driving force I need if I want a constant speed? Or to maintain this, say 100 meter per second, what is the driving force I need? Not kilometer per hour, meter per second example. So if this is a frictional force, the force which is opposing a motion is 200. How much is the driving force, the force required to maintain this constant speed? What will be the driving force? So that will also be 200. So when we resultant force is zero here because the speed is constant. So the force which is required to maintain a constant speed multiplied by speed of object, we can also find what is the power generated by the engine of this car or engine of the vehicle. Is it clear? So when you substitute F, resultant force is zero, but there is a force which is keeping the speed constant, and that we substitute. So this is the last part of today's discussion. Any question related to the class today? I'll share the weekly homework after the session.